Welcome back to another devlog. I'm going to be continuing where I left off in the last devlog, and I'm going to be talking about how I'm using the grid system in my game to manage a lot of the data that I need for both general gameplay as well as the NPC system. If you're new here, I'm working on This Is The Game, the game where you return to an abandoned game project, only to find that the NPCs have continued working on the game while you were gone. The vibe of the game is a cozy psychological horror where you'll be able to make friends with the NPCs, work with them to rebuild parts of the game, exploit glitches, and explore lost parts of the game world. This is going to be a fairly technical devlog. I'm going to try my best to keep it simple, but I do consider this and the GOP system for the NPCs to probably be the most technically challenging parts of the game, so if some stuff is confusing, don't worry, that's because it is. But I'm going to try my best to keep it kind of high level. I'm going to show a lot more of the gameplay and new parts of the game I've been working on in the next devlog, so stick around for that. So when I mentioned the grid in my game, I'm referring to this structure that is comprised of a bunch of 64 by 64 pixel squares, each of which holds specific data. All of this is just attached to a game object in my Unity scene, and it has a script that will take in some parameters for setting up the grid at the start of the game. The grid was originally created for the NPC pathfinding system almost a year ago at this point. It lets the NPCs know the positions of the squares, if they can walk on them, and the cost of moving from one square to another. I also had a separate system for placing objects on the map that worked with Unity's built-in grid system, and this did work fine for the most part, but it was way too confusing and difficult to maintain information between two different systems that were effectively kind of doing the same thing. So I decided to rip down the old object placement system and make one unified system. Going into it, I had three main goals: make it so that the player could place items of different sizes on the map, to move items from just spawning randomly in the world to spawning on the grid, and to make it so that the NPCs are aware of what items are on the map so that they can interact with them efficiently. So the original grid for pathfinding was just an array of grid objects. Grid object represents individual cells on the grid, so each of these squares. Each cell has a position and pathfinding node data. Eventually, I ended up adding a flag that indicates if an item is placed, and I also had a tile render on the grid object, but more on that and why I removed that a little bit later. The main thing I needed was some way to store information for what was on the grid tiles. So I created a dictionary that holds the grid contents. Basically, it just looks like this. The key represents the grid position, and the value is the details of what is located on each grid position. This is held in grid content, which contains data about what is currently on the grid cell, such as the item itself, whether the cell serves as an anchor point for larger items. This is important for items of different sizes, but also more on that later. So now I have the grid, and I'm capable of storing all the information I need, but I still need to get the items onto the grid. So first, there's kind of an intermediate step where we highlight and hover our object over the grid. So first we need to check if all the grid positions that the item would occupy are available. If there are no issues, the item is highlighted normally, and if we can't place the item, it shows as red. The highlighting system is designed to recheck if the player moves their mouse position or their character position over a different cell in the grid. Then when we click on the map, it will place the item at the correct grid position if all of the checks are passing. So to place the actual item on the map itself, this is done by calling place item on grid and remove. When we've selected a placeable item from the inventory and made sure that we are capable of placing it on the map and then click on the map, all this really does is instantiate the item on the map at the correct grid position, so it converts the grid position into Unity world coordinates basically, and then just removes it from the player's inventory and then adds it to that dictionary that is tracking what items are on the map and where. And then picking up the object just involves clicking on the item on the map while holding a key press and then adding it to the player's inventory and removing it by destroying it on the map. And then also removing it from the dictionary as well. And then another thing that I mentioned was I also wanted to modify my object spawning script so that things like trees and resources could now spawn on the grid squares, because before they were just getting spawned at random positions within the Unity world space. But spawning on the grid just makes sure that things won't spawn on top of items that are placed on the grid and helps me kind of just to keep track of what things are where. Now, I ran into a few problems as I was working on the grid system. The first one being, remember when I mentioned that the grid was 64 by 64 pixels for each square? Well, this was based off the fact that majority of my sprites in the game are created with a 64 by 64 pixel scale in mind, including the player character. And this was fine for pathfinding, but when I was working on the grid, I realized I made a huge mistake, that my player was way too small. The distance between the player and the tiles was gonna be way too large when they tried to interact. The player was gonna need like freakishly long arms to interact with the grid tiles. And scaling up the player wasn't really an option because like I said, all of the art in the game is generally 64 by 64 pixels, so now they just look freakishly large. So the only option was to scale down the grid. So I did that, and it just worked. Yeah, nothing broke. Weird. The only thing I had to do to prevent the pathfinding from breaking was scale down the map path tile layer in Unity a little bit, just to also match the 32 by 32 pixels, because pathfinding is just checking where these path tiles are, and it needed to be consistent, but you know, that wasn't really a huge deal. Okay, cool. So we have a smaller grid now, and it's a lot more natural when the player interacts with the tiles. So now I just need to scale the grid up to make sure that it covers more of the map. But this also effectively doubles the size of the grid. And I also mentioned those tile renders in the grid objects. I was mainly using these for coloring the grid squares on the map and handling things like highlighting if the objects could be placed on the map or not. So when you hovered an item, it would basically use these tile renders to change the color of that square to like red or whatever color if you couldn't place an item on there. But when the grid went from about 200 by 200 of those squares to 400 by 400 of those squares, this meant that I was now making 1,600 game objects and attaching a square sprite to them. And this may shock you, but that tanked the frame rate. Just like in the garbage. So then I was like, okay, well, how can I optimize this? Because I think I mentioned this in the last video, but I said that optimizing the grid would be a problem for future me, and well, now it's here. So I thought maybe we can make it so the game objects deactivate if the player isn't near them. Maybe we do math to make sure that they don't spawn in any of the dead space on the map. Maybe I have a script that will already kind of place these objects in the game instead of instantiating them at runtime. Or maybe we just don't have them. Maybe we just don't have the square. The only thing these objects really were doing was adding in a visual representation of the grid squares and handling the highlighting. But if I could just figure out a different way to do the highlighting, then there was absolutely no need to have any sort of game object attached to any part of the grid. So that's what I did. The highlighting now just pulls from an object pool of highlight game objects and places them in the correct location. This effectively took my 160,000 game objects to just like 20 game objects that are constantly being reused instead. I really want to emphasize the concept that the grid system now just exists as data, because this is really important for why this grid system is so lightweight. The grid system itself does not directly interact with any of Unity's game objects. The grid is just purely data structures that store information about each cell's state, content, and other properties. And this is super important for my NPCs, who need to effectively be aware of everything that's happening at the map at all times and all of the different changes that are coming from both the players and other NPCs themselves. The last thing that I had to deal with was the fact that a lot of my items in my game are also 64 by 64 pixels, or sometimes larger. So meaning now they're taking up more than one grid space. Also, I obviously just wanted to generally be able to account for having items of different sizes and being able to place them on the grids, because I feel like that's just really important for being able to make dynamic gameplay. So I needed a way to tell how large an item was, and also how to handle checking the status of multiple squares on the grid by making sure that the item was spawned in the correct place according to its size. And this ended up just involving a lot of math. First was handling the item size, which is pretty easy. I just added a field to my item data structures that keeps track of their size. Then I just had to modify the method that was handling the item tile highlighting. This method calculates which grid cells the items will occupy based on its size. It basically just takes the starting grid cell and then loops over the adjacent grid cells according to the item's size. Then it checks that the positions are just within the grid bounds and that none of the required cells are already occupied. Then once we can confirm that the item is in fact able to be placed on all of these grid squares, then the item is just instantiated in the world. And this was a little bit tricky, but I had to deal with obviously not instantiating the objects directly on the first grid cell, the one that we're currently hovering over. I had to instead make it so that the item would kind of get shifted over and be instead instantiated in the middle of all of the grid cells that it would be occupying. I have this kind of complicated math. This is basically calculating a subgrid within the greater grid for how the item is going to occupy the space. Calculates the center by finding the starting point of the grid cell and then half of the total width of height of the item's occupied space. And the bottom left cell is actually set as an anchor point. This is the main reference point for the item, and this just kind of helps to keep track of the item relative to the rest of the grid and the items on the grid. It's also really important for removing different size items for the grid. Basically, the grid holds the item and the size so that when we click on any spot that the item takes up, it'll remove the correct item from the grid. Like this way we don't accidentally remove the wrong object from the grid, especially if we have, two items next to one another that might technically be the same. And then the grid data structure is updated to reflect this by marking all of the cells that the item takes up as occupied and adding it to that dictionary. And then one of the last steps that I've generally been trying to make a much more conscious effort of doing as I work through these new systems is adding it to the save and load system. I recently finished setting up the save and load system in a much more robust and manageable way that doesn't break easily. So basically I just have a couple different scripts that manage persisting the data for different parts of the games. So for the grid, I have this grid persistence script, which attaches the iData persistence interface to it. And this interface is just the thing that the save system searches for whenever the game needs to load or save files. The save files are separated out according to different IDs because this makes it a lot easier to manage and also prevents one messed up save file from breaking everything in the game. I also generally want to make this game accessible and easy for modding, so I've been trying to keep the data compartmentalized in order to make that easier later. Generally, I don't need a lot of information for the save files, so in the case of the grid, I'm just taking the grid serialized data, which has the grid position, object name, size, and cuttable data. This is more so just relevant for saving the stages of the resources, then saving it as JSON and just loading it back into the grid and instantiating the items when the game starts up. I will say that the grid data JSON looks kind of crazy, but if you look at how I'm saving the player inventory instead, it's a little easier to understand the idea of how I'm basically just putting the data into the format that I want and then undoing it when the game loads. And then this all ties back into the reason that I did the grid refactor in the first place, the NPCs. It was actually really simple to tie the NPC system back into the grid system now. Now that the grid system saves everything in the dictionary, the NPCs can just use that dictionary to find items and then return where they are on the grid. This is just all handled by this find closest grid resource, which does exactly what it says. So it just kind of searches through the grid to find an item of a specific type depending on what kind of action the NPC is trying to complete. So the NPC is trying to collect some resources of a certain type. They can use this and pass in the type of resource that they're looking for and then just find the one that is closest to their current position. So now the NPCs can find the items on the grid and interact with them. I did have this one fun bug where the NPC was kind of blowing up the trees with their mines, but that's fine now. It's fine now. They will also just labor away to their heart's content. A couple other things that I've been working on is setting up new player animations. Now the player is actually several different pieces whose animations sync up. This will be useful later when I plan to implement character customization and whatnot. I also mentioned saving resources. I separated the trees out to have different stages and also track what types of objects can spawn at each stage. This will also just generally work for all of the resources that I'm going to be adding into the game. And I've just slowly been incorporating a bunch of sound effects, particle systems, animations, and generally just fixing a lot of the bugs and things that needed polish in the system. To wrap up, generally, getting the new grid system set up was pretty easy because, like I said, I had already done it. I already had a lot of the code that I needed to set up when I did the pathfinding system. Things like converting the grid system to world coordinates and vice versa were already things that I had created in the past, and I was able to just reuse these pretty smoothly. I've set up a lot of different tools for myself to make the game and development a lot easier and faster, and I've really noticed this recently that things are kind of coming together pretty quickly. Expect some big updates from me in the next devlog, and I'll see you then. Bye!